the inside, that 3 minus 1 half x equals 4, or 3 minus 1 half x equals negative 4. I will subtract 3 from both sides, so negative 1 half equals 1. Multiply both sides by negative 2, x equals negative 2. Subtract 3 from both sides, negative 1 half equals negative 7. Multiply both sides by negative 2, x equals 14. You can always go back and check. Any questions on this problem? Okay, so we have to look at a few things here that are more difficult. The first one is not, but the second one is a different ball game. So 34. So we have x squared minus 16 equals 0. Well, there is only one option here, because only the absolute value of 0 is 0. There is nothing else. So this quantity, x squared minus 16, has to equal 0. And what are the options here? You can factor, you can take square roots. Never quadratic formula because the middle term is missing. I would never do that. But it's possible. So which method would you like to work with? Anyone, please? Choose a method.
Square root.
Okay. How many solutions I have to obtain for sure?
Two solutions.
Yes, because it's quadratic. So what do I get?
Plus or negative.
Excellent. Perfect. Now the next one is a different ball game. The absolute value of x squared plus x equals 12. The same two options, there is no discussion there. X squared plus x can be 12, and x squared plus x can be negative 12. Now in this case, we have quadratic equations. Not that difficult. It appeared to be difficult, but that's really not the problem, not the issue. Good. So since it's quadratic, what do I have to do first? No matter what method I use.
Rearrange.
Yes. So I need x squared plus x minus 12 equals 0. And since it's not difficult to factor, let's factor. The same thing here. X squared plus x plus 12 equals 0, and it's not difficult to factor, then let's factor. The leading coefficient is 1, no greatest common factor, no negative leading coefficient. Easy. Easy peasy. Can anyone will anyone be willing to give us the factor form of any of them? Any of them? Anyone?
The first one
Yes.
would be x plus 4, x minus 3.
Indeed.
And then the second one is just x plus 4, x plus 3.
It turns out that I spoke too soon, because the product is 12 and the sum is 1. So let's use the quadratic formula, although I already know and I see that the discriminant is negative. 1 minus 4ac. So these are not real. Sorry, I spoke too soon. So the only options are x equals negative 4 and x equals 3. Oh, x equals negative 4 and x equals 3. There are no options here. X squared plus x plus 12 has imaginary solutions, and it's always very easy. I showed you with the graphing calculator last time. You can always verify that. Very easy. Put it in apps, polynomial root finder, it's 2. But be careful how you enter the coefficients. They have to be in the correct order. 1, 1, and 12. And you will see that the solutions are imaginary. not sure what I'm doing here. 1, 1, and 12, and you will see the solutions are imaginary, as expected, because the discriminant is negative. B squared minus 4AC, as expected. Good. This completes this review of 2.8, the absolute value equations and expressions. We will have other expressions from other handouts if you'd like. We'll take a look at more. I'd like to start, I know we only have, 10 minutes. Don't let me go over. I don't want to hold you over 8 o'clock. So, we have the next handout on, this is all review from 145, and this handout triggers sections 4.3, 4.6, and 4.8. They're all review, everything was done in the previous class. But let's consider a thorough review, so let's work on these problems together. So we're going to look at solving exponential equations and logarithmic equations. So let's start. I'm on page 10. Okay, so we have the first one, which is 76. 5 raised to x squared plus 8 equals 125 raised to 2x. Okay. Notice that the left-hand side cannot be simplified or changed into any expression. It is what it is. But when I look at the right-hand side, I realize that I cannot do anything with 2x, but there is a way of rewriting 125. What will be that way? What is that other option for 125?
Would it be 5 cubed?
Exactly. Thank you so much. Thank you, Asa. Very good. So, why am I doing this? And you can say, just apply log to both sides. True. Yeah. But this is too easy. Because I copy the base, I keep the exponent as is, but here I have 5 to the third, everything raised to 2x. I copy the base, which I like because it happens to be the same, and what will be the power now? Copy the base, what happens to these powers? What operates?
X.
Indeed. So what happens now is two exponential expressions with the same base are equal. What has to happen for these to be equal? And there is only one correct answer. What has to happen? Sorry?
Sorry. You can set the exponents equal to each other.
Of course, it's a must. If they are equal and they have the same base, x squared plus 8 must equal 6x. There is no other way. And this is back to a quadratic. That's why we reviewed quadratics. I have to arrange it in the descending order, in the correct order, everything, and try to factor. If it's not factorable, I move on to a different method. But it is factorable. Anyone would like to factor this?
X minus 4, x minus 2.
Very good. So then x equals 2 and x equals 4. Exponential equations don't have glitches. They're not radical. I don't have to go back and check unless you want to. If you want to, you can always, if you want, use the calculator. And here's how I do it. If I want to check, I put in 5, I put in power, and I'm checking, let's say 4. I put parentheses, because I love parentheses. So I have 4 squared, which is 16 plus 8. You don't even have to calculate. Minus the other side, 125. And the power, in parentheses, 2 times 4, which is 8. When I click enter, what should I get if 4 is indeed the correct solution?
Zero.
Thank you. Who said that? Isaac, thank you. Of course. If it's not 0, I'm in trouble. And I repeat for x equals 2. Is there another way? Yeah, you can do them separate and you'll see that you have to get the same answer. But I prefer the 0. It's up to you, of course. Good, excellent. Now the next one, any questions on this? Okay, the next one is 82. And it's e to 4, everything to power x, times e to x squared equals e to the 12th. Look at how many e's in here. Okay. Well, I have to clean it up. I can't decide what to do before I clean it up. So, what do I write for this, first of all? The right-hand side is the right-hand side. No one can change that. But I have to simplify the left-hand side. And how do I do it? How do I rewrite this?
E to the 4x.
Of course. Thank you so much. Who was that? Blake, thank you. E to x squared. Now how do I simplify this? I multiply two exponential notations with the same base. I copy the base. I can never touch the base. I copy the base. What happens with the exponents?
It turns into an equation because you can add them together.
Yes. So we have 4x plus x squared. Excellent. Luckily, both sides have the same base. For these two to be equal, what has to happen? How do I continue? Anyone?
4x plus x squared must be equal to 12.
That's it. There is no other way. X squared plus 4x minus 12 equals 0, and I will factor. It's an exponential equation. It's legit. I don't have to check unless I want to. Unless I have doubts about my steps, whatever. But checking is not part of the solution. It is when I solve radical equations. That is part of the solution. For rational equations, I have to state restrictions, and I have to check against restrictions. Here, it's all safe. I will not be able to say the same thing about log equations, though. They are not safe. So, can anyone give us the factor form for this?
X plus 6x minus 2.
Very good. So then the options are -6 and +2. Great job. Looking at the time, we have 5 minutes. So let's choose one or the other. Well, let's continue with 47, and then I'll stop, I promise. And this is page 11. And the last problem for tonight is 5 times 2 to 3x equals 8. And that is 47. I was hoping to finish this handout tonight, but we barely started, but it's okay. Okay. No, you cannot distribute. There is no distributive law here. You can divide both sides by 5. So 2 to 3x equals 8/5. Unfortunately, 2 and 8/5 can never be presented with the same base. Lucky situation. Lucky situation. But not here. 2 will never be written as 8/5 or vice versa. I can only apply natural log or common log to both sides. Does anyone remember a property? What happens to this exponent in the log expression?
bring it down, can't you?
in front as a factor. As a factor meaning multiplies natural log 2 equals natural log of 8/5. All I have to do to find x, this over this, 3 natural log 2. If I'm asked to approximate, be very careful how you do that. Let's do it together. The numerator is fine. Natural log of 8/5. Careful now with the denominator. I have to put either parentheses or divide twice. So, again, you either put parentheses here, or you divide this expression by 3 and then divide by natural log 2. One or the other. If you do not put parentheses, then you have to divide twice. Be careful. I will use parentheses. I'm enamored with parentheses. Okay? So I have natural log of 8/5 at the top. And in parentheses, I want the calculator to perform this first, and then divide this by this answer. And I press enter. Whatever this is, depending on how many decimal digits they want us to use, I will always go back and check. Let's check. 5, parentheses, here's how I check. 2, power, 3, times the previous answer. I don't want to truncate that, because I'm not going to get 8 if I do. So if I enter 0.2260, I will never get 8. But I want the calculator to bring back the previous answer. But it has to be the exact previous answer, not if you have other calculations in between. It's not going to take the previous answer, right, that you want. So when I click enter, if I don't get 8, I'll say, oops. That's how I check my answer.